Alright team, so in this unit we're going to get a static electricity. So we need to see where electricity comes from. Well, it's really back to chemistry. It's just protons, neutrons, and electrons. So as a refresher, protons are positive. Protons are in the nucleus. They're also not free to move. Electrons are around the nucleus. Again, they are free to move. They are negative. So these are really where electricity is going to come from. Neutrons are neutral, so they don't really do a whole lot with electricity. So what's going on with this interaction? Well, the interaction from these particles causes electricity. So the big piece you need to understand is opposite charges attract, like charges repel, and then now we're going to show you this. Again, it's from these electrons being free to move. They are really free to move in a conductor. Electrons can move in an insulator. Electrons can move. So let's take a look. Wrong one. So if I take a look at this, essentially what's happening is you can take a balloon and you can rub it, and by friction you can pull electrons, because electrons are free to move, and so they're able to pull off here. So now if I set it over here, it'll stay there. So now there's something I want to show you, is really that even though they had all these charges, these ones all cancel out. So you're only left with all these extra positives, and then this one, these four cancel out, but you're left with all these negatives. So really what the electrons and protons see is this. So again, right here, you have a opposites attract. So if I let go of the balloon, it attracts. Right? Now, the other thing is people will notice, well, how does it stay against the wall? Right? And so let's look at that. So what happens here is you can have a neutral object, so it has a whole bunch of protons and electrons, and if you bring this near it, since this is filled with electrons, these electrons push the other electrons away because electrons are both negative, so like charges repel, so it pushes away those negatives, so then the negatives attract to the positives. And so that's why we have a balloon that'll stick to a wall based off of polarization. I also showed you an example in class a long time ago of a balloon attracting water. Water is neutral, but this is exactly what's happening, why a stream of water is attracted to a balloon, because that's what we have happening right there. On this one, let's take a look here. Okay, so again, John Travolta, friction, he's rubbing, and he pulls all of those electrons onto him. Now, do those electrons want to stay near each other? No. So you can see they're pushing. Those like charges repel. So as we keep going, they spread out. Okay? Now, eventually, those electrons will want to go somewhere. Okay? And so here, when his hand gets close enough to somewhere for them to go, they all jump out. This is also how electricity works. Right? Or sorry, how lightning works. So as the clouds, molecules are bumping, typically it happens when there's a lot of freezing. If you're going to have hail, hailstorms will typically have a ton of lightning because all those hail molecules are bumping into each other, pulling electrons off. So those electrons build up. Now, this is the cloud, this is the ground. There's not enough electrons, so there's no lightning. But if you keep going, I built up all those electrons, they repel, and they go down, and that's why you have lightning. So that's our basis for electricity, about all that you'll need. You'll see a whole bunch more later on.